Hello and welcome to today's webinar. My name is Dara and today's webinar presenter is Simon Stewart, and he'll be presenting automated web testing traps for the unwary. The webinar will last about 45 minutes in total, and then we're going to have a Q&A session directly after. You can join the conversation on Twitter at #ESComms, and you can also find today's presenter at SHS96C, so if you want to connect to them. So without further ado, let me hand you over to today's webinar presenter, Simon. Hello, Simon, you there?
I'm here. Just pull up the presentation. Okay, can you see that clearly? I hope so.
Yeah.
Brilliant. Okay. So, my name is Simon Stewart. I'm the creator of WebDriver. I'm the current lead of the Selenium project, as Dara pointed out. And I'm here to talk to you about the 3 things you need to know in order to make your Selenium tests stable, maintainable, nice to use, and all that stuff. Commonly, these are traps that Unwary users or new users of Selenium and WebDriver stumble into. So hopefully, this will help you write better tests and be more useful. I understand that if you've got questions, you can type them into the little chat box and Dara will be collecting them. I'm happy to answer those. Cool. So what are the 3 things that you need to know? Well, put simply, the 3 things are: how do you find things in a page? How do you wait for things to happen? And the final thing is, once you've written all your tests, how do we make it possible to maintain? So let's start off with, how do you find things? So the main way of finding things in the WebDriver API is through a command called findElement. And that takes a by as an argument, and there are a number of these. If we go and take a look at the API here, you can see that we can find by class name, CSS selector, ID, link text, name, part of a link text, tag name, and XPath. Realistically, although you've got all those options, the ones that you're going to use are ID, which is for finding an element by the ID attribute on a page, name, which is really useful for finding elements in a form, CSS selector, and XPath. These are the ones you commonly see. The interesting thing is that we violate the W3C specifications with IDs. IDs are meant to be unique on a page, but commonly web applications are written in a way that means that the same ID is used in multiple places. If you find that the case, you can find multiple elements with the same ID and everything will work the way you expect it to. You'll notice that I put XPath in that list of locators. Generally, the use of XPath is discouraged. It seems really attractive. You know, you've got this sort of HTML document and it's organized as a tree, and you know, it's like an XML document which is also organized by a tree, and the way that you find things in an XML document is you use XPath. So, you know, why wouldn't you apply XPath in the same way to the HTML DOM? So the tools that we use for extracting the XPaths tend to lead to very brittle XPaths. The other reason is that even if you can craft the XPath expressions, there are differences in the way that XPath is implemented between browsers. And a feature that you rely on in one browser where you're writing a test may not be present in another. The classic example of this is that when we're talking about Internet Explorer, there is no XPath engine. In order to let Selenium and WebDriver do the searching on the page using XPath, we need to implement our own XPath engine. And we've done that in JavaScript. Now, JavaScript is a fine language, and we all love it to pieces, I'm sure. But the problem with JavaScript on Internet Explorer in particular is that it's quite slow. So not only will using XPath lead to brittle locators unless you're very careful, but on the one browser where we actually care about performance, where things are incredibly slow, we've got the slowest finding mechanism. So that's less than ideal. Can I move to the next slide? Let's click on this button here. There we go. So XPath is normally a really bad idea, but sometimes, too far, just occasionally, it's not. Now, sneak peek, by the way, the next slide is all about CSS locators. So sometimes it's not a bad idea. And the classic example here is where you've got a component on the page and the ID is fairly low down and you want to move up the DOM, so you want to go to the parent element. Generally, in that case, it's okay to use XPath to find an element because you'll use the XPath expression ... meaning parent node, and you'll be returned up the tree. The other time it can be a really good fit is when you're searching the DOM, you're searching for an element by attribute. So say, for example, you've got a custom attribute that you've added to all your key elements, like my element ID. You can then use that to find the element quickly and easily. So although it's not always a good idea and it can lead to brittle tests, sometimes there is a time and a place for using XPath. So what should you use instead of XPath locators? Well, we recommend using CSS. So CSS locators are really, really good, mainly for several reasons. The first reason is that while XPath expressions tend to only be used by the testers on a project, CSS locators are used by far more people. So the designers and the UX people on your project rely on it, and your developers are probably cognizant of the fact that these people use it and will try and maintain them. That means that you can maintain your tests far more easily because there's far less change going on. As a tester, quite often your developers aren't aware of the fact that you've got XPath expressions littered through your code, and they change things in a surprising way. The other thing that happens is that the tools used for extracting CSS locators automatically in browsers tend to lead to less brittle CSS locators. They're less cognizant of the structure of the page, and therefore when people do minor refactorings of how the DOM is constructed, the CSS locators continue to work. That's really useful, right? CSS locators are fantastically easy to learn. If you're not familiar with them, head on over to the W3C schools, and there's a quick introduction which will teach you everything that you need to know. The other way to find elements doesn't rely on using the by interface. What you can do is you can use a thing called the JavaScript executor. The JavaScript executor, I've got the API on my machine here. Oh, crikey, that's not what I wanted to have. Is a fairly basic interface that allows you to execute script. Any JavaScript you can put in there can return a function. So you can do return some JavaScript function like document.body. This is really useful when you're doing a thing that I like to refer to as grey box testing. So normally when you're doing a testing of an application, in some companies at least, the developers throw the application over the wall and there aren't any hooks to make it easy to automate. Having those hooks will make life a lot easier. So for example, jQuery provides a thing called active, which gives you a list of the currently active operations, and the size of that can be 0, and that's kind of cool. Another example is in Gmail. Gmail is an incredibly complicated app. It's incredibly hard to automate. Every release, they change how things are laid out. But it's got this sort of accessibility class called gmonkey, which they ship as part of it. And you can get the gmonkey through JavaScript, and you can say to the gmonkey, can you give me the left-hand navigation, the thing that contains the inbox and the labels and things like that. And you can use that to sort of simplify the testing. So what you can do is you can say, JavaScript executor, please return me, and interact with an element on the page. And that can be a really powerful way of finding classes, particularly if the application under test has been modified to make it easy to use this mechanism. Are we going to go to the next slide? We are. Excellent. The other thing you can do is it's pretty simple to extend WebDriver by writing custom bys that are specific to your particular use case. And I've got 2 examples on this slide deck here. The first one is a locator by ARIA. So ARIA is a specification for doing accessibility on web applications, and quite often you'll see that people have assigned an ARIA role to a random collection of divs which get styled as a button or something like that. And those are called ARIA roles. This top example here simply provides an expression to allow you to go driver, find element by ARIA role, and give a role name. And as you can see, this is one of the few cases where using XPath is a good idea. We want to find by a custom attribute. There isn't a find by attribute method in WebDriver, and so we return this locator. Now, if role happened to contain the apostrophe character, there'd be problems, but as an example, this is pretty good. A more complicated example is shown underneath. We've got jQuery, which is hugely popular and used all over the place. I'll walk you through this method because it looks vaguely terrifying, but it's not too bad. So the first thing we have is we return a new by, and we're creating an anonymous subclass. This is in Java, in normal Java. The anonymous subclass needs to implement only one method, this find elements by search context. Now, a search context is normally a WebDriver, but it could be a web element. What we want to be able to do is use the ability to execute jQuery, the ability to use JavaScript even to do the search for us. So what we'll do is we'll make sure the context we're given can execute JavaScript by checking to see whether it's an instance of JavaScript executor. If it's not, we warn the user. We then execute the jQuery we're given, and in order to return a value from JavaScript, we need the return keyword. So we return whatever jQuery script we were just given, and we collect the value. Now, we're not quite sure what comes back, but we might have nothing being found, and that's okay. We just return an empty list of results, and that gets returned to the user. Now, the jQuery we've been given may find just one element, or it may return a list of elements. We're going to assume in the common case that it's a list. And we just do a quick check here, and if it is, then we return the value. If, on the other hand, we've only been given a single DOM element, then we can execute this particular line here, which will make a list with one element in it, which is the value we've received. If it's neither a list nor a web element, then we throw an exception and just say to the user, I'm sorry, the thing you returned wasn't what I expected. That's a pretty simple example, but it shows you the sort of things you can do. I hope that makes sense. Cool. So now we know how to find things. We now need to understand waiting. Before we can understand waiting, we need to understand how our web application communicates with the server, because this is the cause of many of the pauses that we get in our applications. Generally what happens is when you've typed into the URL bar, a request is sent off to the browser, to the server. The server takes a little bit of time to respond and then spools the results across the wire. And in this particular case, you get the Google homepage. But then if you were on the Google homepage and you were to type into that search box, I would like to find cheese, for example, each key press ends up being sent back to the server, acted upon, and results sent to the browser, which then takes those results it's been given and it renders them to the screen. You've probably seen that if you've used instant search on Google. It's pretty simple. And that sort of technique, using a thing called the XML HTTP request, is common in modern applications. It's a technique called AJAX, which you may have heard of. So the problem is that whenever we do one of these round trips, there's a pause that we need to wait for. The WebDriver APIs and the Selenium APIs execute as quickly as they can. So if you say to them, go and find me an element, and it's not on the screen, they'll return instantly and go, I can't find that particular element. How do we avoid this problem? We will come to that in just a second, but there are other causes for delay. Notably, when you're using WebDriver, we've got a thing called native events. So we fire events at the operating system level when we're emulating a user, particularly on Windows. That means that we can fire a click event, and although it'll be going to a particular element on the DOM that is a button, we may have returned before the click is completed and before the request has been sent to the backend server, or before any JavaScript on the page has had a chance to interact with it. Sometimes people use window.setTimeout in order to run regular tasks. There was one project I was on where window.setTimeout was used to update a model every quarter of a second, and WebDriver would complete all its actions within a quarter of a second. The model would not have been updated. And so when we went to interact with the other parts of the page, the JavaScript within it would go, the model is out of date and isn't valid, and would throw an exception. Unless we added a tiny, tiny sleep, which wasn't good, and that's because people were using window.setTimeout. Local JavaScript processing can take a finite amount of time. In fact, it does take a finite amount of time. Normally, it's okay, but if you've got a particularly complex operation that's being done, like, I don't know, you're working out prime numbers, then it may take a while. And finally, HTML5 starts to offer some really interesting capabilities, like web workers, which allows you to assign a piece of work to a background JavaScript thread, and then those results will be posted to the main UI and acted upon. That process takes time. All of these things, including the round trips to the server, cause delays, and your tests need to be able to handle them. One way to handle these waits that need to be added is to add them implicitly. And here's an example of how to do that. You'll see that the first line of this particular script, which again is in Java, creates a new Firefox driver. We then say to the driver, can you please implicitly wait 30 seconds before you do anything? We go to the page example.com. Now example.com may be fairly simple, but it may be a GWT application, for example. The driver.get method returns when the onload handler has fired on a page. Now with a GWT application, that firing of the onload handler causes a whole chunk of JavaScript to be executed, some XML HTTP requests to be sent, and it constructs the DOM on the fly. It's fairly impressive. Now, if I was talking to a human tester, I would probably go, hang on a second, you need to wait until that DOM is finished. But in this particular case, we've set an implicit wait. So when this driver find element by name, username, so apparently we're doing a login, is executed, if the element can't be found on the page, it will pause for a second, and then it will rerun that search. And it will rerun that search for a certain number of times, up to 30 seconds. If at the end of 30 seconds, the element hasn't been seen, then we throw a normal no such element exception, and the test will fail. If, however, within that 30 seconds the element appears, we can then continue through to executing send keys, and so on and so forth. At the bottom of this, I've got another example where we're loading up some sort of fancy menu, which is probably going to be some jQuery executing locally. Now, it's possible that that sort of construction of the menu takes a certain amount of time. It may be done with an XML HTTP request, and again, we want to wait, and so that method will do the waiting again. So implicit waits look really awesome, right? You no longer need to be aware of, how the server is communicating with the backend and where the pauses might be. You can just write the test really easily. The problem with them is that they tend to fail slow. That is, presumably once the username has appeared and the ability to log in is available, the username, password, and submit fields will all be on the page. It's unlikely we're constructing the page on the fly. But if the password field isn't called password, it's called password, or we somehow mistyped that, what will happen is we'll wait up to 30 seconds to find that username, that's fine, and then we'll wait up to 30 seconds more to find that password field, which isn't there. We really, really would prefer to be failing fast, right? And that's the main problem with implicit waits. They make your tests fail a lot more slowly than they should do. And typically you see this in the form of your test results going from a handful of seconds for a Selenium WebDriver test to well over a minute. And it's because the implicit wait timeout has been set too high and an element can't be found. How can we avoid this? There we go. I waited for a second as I just wanted to make sure the screen is updated. The way we avoid this is using something called explicit waits. So this is the same test rewritten using an explicit wait. We get our driver instance, and now we instantiate a thing called the WebDriver wait. And we give it the driver instance, and we say, look, wait for up to 30 seconds before doing anything. So we've got that same timeout that we had before. We go to example.com. We now see that the username, password, and submit fields are not generated using XML HTTP request. They're present on the page once the onload event is fired. So we just go ahead and find them. And if the element wasn't present after that call to get had completed, then an exception would be thrown straight away. We would fail that test fast. But you see here, when we call click, we are expecting there to be a certain amount of time taken. Perhaps we're using native events. And as you remember 2 slides ago, sort of native events are one of the reasons why there might be a pause. That click may have returned before all the processing of that click had continued. Or perhaps, we're loading a bunch of data, and this is the point where sort of Wait pulls in all the fancy content. But that's okay. We can now use our explicit wait. As you can see on the bottom here, we wait until the visibility of the element located by ID fancy menu is there. Compare that to the previous bottom line on the slide. We did driver.find element by ID fancy menu. And now we're saying wait until it's visible. So this is not a huge amount of overhead to add, but it makes it very clear that we're now expecting there to be some sort of slow pause here, which has been added for some reason, and it probably is because we're doing some sort of JavaScript processing. You can normally tell the fact that you need to put explicit waits into your code base if you've got some flakiness in your test, and that flakiness is demonstrated either by a no such element exception or in rare occasions by a stale element or reference exception. One way to figure out where to add those explicit waits is to reintroduce some stability to your test by upping the implicit wait timeout and then adding it, slowly dropping it down towards 0 and finding out where you're seeing instability and adding an explicit wait there. On the other hand, if you're a developer and you're writing the application and you're aware of where requests might be made or where there might be processing done, you can simply add the wait yourself, and that's okay. I hope that all makes sense. If there are any questions, I will be answering them later. Hit the forward button. Cool. So if we were doing the slides on my machine, I will be showing you these particular classes, but we're not. If you're familiar with UML, this is the hierarchy of waits that are available in the Selenium WebDriver project for Java. There are similar classes for Python, Ruby, and for C# as well. At the top of the pile, you've got wait, which defines a single method, .until, and the wait takes a particular type of thing, which we call f. A subclass of that is a fluent wait. So fluent wait implements a style of API design called a fluent interface. You may have seen it if you've ever come across builders, but it allows you to modify the exceptions that are waited for, as well as a bunch of other fields, such as the timeout that you're going to be using, how often polling is done, and what to do when a timeout expires, so what message to display to the user. Interesting. The final specialization of that is a WebDriver wait. So a WebDriver wait is a fluent wait that is specifically coded to take a WebDriver instance. And that's what we used in the explicit wait example in the previous slide. You'll see here, going back to the top, we've used the general interface because we don't care how it's implemented, but we do say it takes a WebDriver. And we've got a particular instance of it, the WebDriver wait. Those are the key classes and interfaces that we use when dealing with waiting in WebDriver. They're particularly useful. So that until takes a variety of different conditions, like how do you know what you can wait to? WebDriver wait and all the waits take a function, and there's a specialization of function called an expected condition, and WebDriver ships with a number of pre-canned expected conditions which may or may not do what you want, but cover many of the common cases. It's quite common that you won't need to write your own. Expected conditions can cover things like, and I'm sorry for the tiny text, waiting until an alert is present, or waiting for an element to be clickable, waiting for an element to be present on the DOM, or waiting until an element disappears, staleness. These are all kind of useful. And you'll notice in these method signature that they've got what they return. So wait until an alert is present, returns the alert once it's present. Waiting until an element is present on the DOM, we'll return the element once it's found. Going back a couple of slides, that allows us to write code like this, which says wait until visibility of element located. This is on the expected conditions, and it returns a web element. That allows you to avoid one of the really common patterns you see, which is to wait for something to happen, and then do, and normally that waiting is waiting for an element to be present on the DOM or to have reached a certain state. And then people do another find immediately after that. And you can avoid having to do these additional finds this way. If those expected conditions aren't enough, then you can write your own. And it's pretty easy. You just extend the expected condition class, and you can implement any logic you want. Here's a frivolous example that I threw together as an example, and it says, hey, look, wait until the word cheese is seen. So what we get given is we get given a driver instance in our method, which is the only one we need to implement. We find the body, and then we call getText, and we see whether or not it's got the word cheese in it, and we return true or false. The wait classes are programmed to wait until either we return something that is not null, a proper object, like a web element, or we return a Boolean whose value isn't false, or put more accurately, a Boolean whose value is true. So if this was added to a wait, this would continue to be executed until the word cheese appeared on a page. Hopefully that's pretty clear. Again, if there are any questions, I'm happy to answer them at the end of the webinar. And that leads us on to code. You've seen already that in a couple of cases, we've been writing our own extensions to Selenium WebDriver to make it easier and more appropriate for our own testing needs. You saw that when we had the custom buys. You've seen that now with the expected conditions. And now we go into code. I'm a big fan of a particular style of coding called object orientation. One of the nice things with object orientation is it allows us to reduce the amount of repetition. By the way, I'm not going to go too deep into the coding. I realize that the audience of this webinar may not be particularly comfortable with huge amounts of code, but I really do think it's important to have some level of skill with some programming language. It'll make your life a lot easier if you can automate these repetitious, boring tasks, and it'll free you up to do interesting things like doing exploratory testing or security testing, or just going and having a coffee and chatting with your friends as the automated tests run. What we want to do, though, is we want to make sure that the automated tests we write are easy to maintain and simple to keep up to date. So, going back, I'm a big fan of object orientation, and the key languages supported by Selenium WebDriver are all object-oriented. Java and C# are compiled languages, and you run those normally in an IDE. You write those in an IDE, and then you run them either through the IDE or on the command line. And the other two are scripting languages, Python and Ruby. If you're not familiar with code and there's no one else around you to help, I recommend taking a look at Ruby or Python. They're both excellent choices, and they're both quite lightweight and easy to use. If, however, you're sitting near the development team, I'd go and have a look at what they're using, and I would use the same language for writing my tests. Now, that isn't a hard and fast rule, but by doing that, what it allows you to do is go and talk to the developers and go, I'm stuck on this particular thing, I need a hand. It also allows the developers to maintain the tests, which allows you to look more awesome because you get more done and they're doing some of your work for you. That's brilliant, right? So if you're going to keep your developers happy, or if you're going to keep yourself happy, one of the most important principles of software development is this concept of not repeating yourself. Now you can take this to extremes, but put most simply, if you find yourself writing the same 4, 5, 6 lines of code, it's probable that you've got a method or a function that needs to be extracted. Simple examples might be setting up initial test data or going through a series of steps in order to find something on a page. If you're using an object-oriented language, perhaps you're going to be modeling things on the DOM. So you might have a table class or a select class to model key parts of the interface. Or maybe you're using a custom set of UI components that your developers have worked together. and you probably have an object representing those. By reducing the amount of repetition, you make it easier to fix things when things break, and you can start applying some of the basic object-oriented design principles. Moving on a slide. There we go. Woo! So object orientation is basically the idea of modeling, rather than a list of instructions, things. If I was going to do an example of an object-oriented boil a kettle, I'd probably say, you know, if I was writing it really simply, I would go find the thing that is the third item on the shelf, lift that thing that is the third item on the shelf, take it, move it 10 meters to the right and 1 meter to the left, 1 meter down, put in front of this, press this, and that's mind-blowing, right? That's the wrong level of detail, and we don't think like that. What we think of is like, take the kettle off the shelf, walk down the apparently incredibly long kitchen, put the kettle under the tap. Page objects are applying this OO principle of modeling objects to our code. And they're sort of Janus-like. So Janus was the Roman god who had two faces. He's the one that January is named after. And he looked forward into the future and backward into the past. In our particular case, page objects are Janus-like in that, looking outward toward the person writing the test, they reflect the services offered to users. So the example I always use is the login page. A login page offers the service of being able to log into an application. So that's a service facing outward. Facing more technically and toward the user, it has deep knowledge of the page structure. So you might log in as a particular user, but the login page would be aware of the fact it needs to find a particular element on the page, and it needs to enter the username into this one and the password into this one, and then it needs to be clicking this. The other thing is that the page object is terrifically misnamed. The name that tends to lead people to believe they can only model a top-level page. If I had my time again, I would be renaming this pattern component. Your page is probably composed of a series of components. So going back to the Gmail example we had earlier, once you're logged into Gmail, you've got the left-hand navigation, you've got the chat window underneath it, you've got the top-level navigation including the search bar up there, and you've got the inbox. Each of those could be modeled as a page object. There we go. So, you know, once you've got a page object, WebDriver provides a few utilities that make it easier to write these things and maintain them. The first one we're going to cover is the PageFactory. The PageFactory saves you having to do, saves you having to constantly do driver.findElement, blah, 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 driver.findElement, blah, 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 driver.findElement, blah, blah, blah. The aim of the game is to remove some of the duplication that you're going to see. Again, applying don't repeat yourself. You can see here that it's pretty easy to use. We simply pass in, and the final line of the constructor of the page object, the driver we're meant to be using, and a reference to the thing to decorate. In this case, the object we've just created. And you'll see that we've got some final fields, a wait and a WebDriver. They won't be touched. And we've got these two elements, menu and navigation. And you'll see that the menu has been annotated with the find by ID. That means whenever we refer to menu, if we were to call menu.isDisplayed, the PageFactory would have added something that allows us to find an element with the ID top nav, and that would be what would be returned. The only thing is that every time we'd call a method on menu, it would go and find it again. And that can be hugely expensive, particularly since quite often that element is there and it doesn't change for a very long time. So we can cache the lookup, and that's what the second annotation does. This annotation says that if we were to try and interact with that element navigation, we would do a lookup for an element with the ID TOC, presumably table of contents. And then once we'd found that element, we wouldn't look it up again in the lifetime of this page object, this home page. And you can see us using it here. We wait until the visibility of navigation, which simply calls isDisplayed. We're passing it the concrete, the actual implementation rather than the locator. So it will call is displayed numerous times until that element is present and visible, and then it'll return a new navigation object. So this is one of the other things that's quite nice. The page object we're modeling is returning the next object that you're going to see. And that allows you to compose the tests in a really nice way. You know, you can go home page, get navigation, do this. Why do we do this? The main reason that I do it is that it reduces the amount of time it takes to write my tests. You know, the reason why we're writing the tests is to find out when the application is broken. If we change the workflow of the application and how things work, by causing the tests to not even compile, we don't need to run them, and we know what's going on. If we, for example, if the navigation wasn't present on the home page, we could remove this method entirely, and our tests would no longer compile, and life would be easy. We like the easy life, right? Okay. So the other thing we'd like to be able to do is just be able to go, you know, new up one of these things and go straight to it, right? That can be done with a helper class called LoadableComponent. Don't worry about the somewhat odd-looking signature here. Almost always the thing that goes, the specialization is the class that we're creating. In this case, homepage. Somebody allows a get method to be created that works the way we expect it to. This class is identical to the previous one, but instead of just being there, it now provides a get method, which isn't listed here, and that get method is is implemented with a call to are we loaded, is loaded, and this says, look, we're not loaded or we are loaded, and if we're not loaded, then we can call driver.get, and this will cause us to navigate to the page we want to. That's really great, but you remember right at the beginning we were talking about how, you know, sometimes the application takes a long time to get going. For example, if you're using GWT and you're downloading a bunch of JavaScript and that JavaScript is being executed in the local host, and then as it's being executed, we're constructing the DOM and then we're putting things up on the screen. That process can take some time. To help with this, there is a slow loadable component. This is exactly the same as loadablecomponent. It will call isLoaded, and if isLoaded throws an error. So this allows you to use normal assertions, which allows you to return really meaningful content to the test runner, which allows us to communicate with the user why the test failed in a sensible and meaningful way. If, however, this isLoaded fails and load is called, isLoaded is now called in a loop. How many times is it called in the loop? Doesn't really matter, but in this particular case, it'll be called up to 30 seconds. So maybe the element isn't present, we construct the DOM, and within 10 seconds, this is returned. That's pretty easy, that's pretty basic, but that's a really quick introduction to slow loadable component. The rule of thumb is if you expect the element to already be on the page, use a loadable component. It's pretty easy. If, on the other hand, you expect the construction of the page to take a certain finite amount of time, then do take a look at using slow loadable component. It'll reduce the brittleness of your tests. And I tend to write my page objects using one of these two. But there's no need to, if that's what you don't like. You know, if it looks confusing, if you're worried about it, that's fine. There are loads of other ways of writing these tests. I've covered a few, which are my favorites, but you can go and take a look at alternatives. Common ones that I've seen are narrative-based frameworks. So there was a framework that for a while was taking off called Generate. I think it's kind of stalled now, but that allowed you to, rather than use page objects to model things, allowed you to model the users and the interactions they wanted to have with the page. So it's a different way of looking at the same problem. Some of you may have heard of Cucumber or Gherkin, and you may have heard of something called BDD, or Behavior-Driven Development. That's great. You can write stable tests using BDD, scenarios and steps. I tend to find that those scenarios and steps take advantage of page objects that I've written. So I may not be using straight WebDriver in the steps, but I am probably using page objects, and I'm probably composing the steps of those. And if you're a particularly sophisticated tester, or if your development team are sort of into that sort of thing, perhaps you've written a domain-specific language, which is unique to your problem domain, and allows you to completely and really clearly explain what goes on. If you took a look at my very first WebDriver presentation back in 2009, maybe even before that, I actually wrote a DSL over the top of the original WebDriver that allowed me to use a framework called Fit, which was a table-based framework. So, maybe you could use a keyword-based approach and have those keywords delegate down to WebDriver. Whatever you do, the idea is to keep your code simple, clean, and maintainable. I do that by applying object orientation and applying the don't repeat yourself principle liberally. You might take different approaches. If you're interested in this stuff, I really do recommend reading around it. You could also, if you were keen, Google for a thing called the SOLID principles, SOLID. I think Bob Martin came up with that. They're really interesting and a really great way to start getting to grips with object orientation. And with that, I'm going to see if there are any questions that I can help you with.
Okay, thanks very much for that presentation there, Simon. And we can now open the floor to questions from our attendees. So if you have any questions, please just type them into the questions field on your control panel. And the first question I have for you here is from a Christian Clark. And his question is there a good and sure way of checking for a specific text on a page without specifying the CSS locator of the element? I've tried looking at the page source.contains, but I don't think that's a good solution. If you have any ideas, that would be great.
Sure. So actually, there was a demo of this right at the beginning, where you find the body element, and then you get the text of that body element. So you call driver.findElement by tag name, body. The element that comes back, you can call element.getText. And that will show you the visible text that a user will see. The problem with that is that getText does a number of computations to figure out whether or not a user would be able to see the text that's present, and it can be quite slow. So that would be the way I would do it, but be aware that it will introduce some slowdowns into your code base. If you can narrow down the part of the DOM that you're searching through, maybe not completely, but maybe a slightly smaller section of it, you can take the same approach of calling getText and taking a look at that. If you're using wait and the expected conditions, there is an expected condition, which I believe is called text to be present. Hopefully that helps.
Okay, thanks very much. And if you have any other questions now,
another question?
I'm just waiting. There's another question here from a Richard Bradshaw, and the question is, how would the load method on a page object work if you wanted to check the navigation tool if the navigation took you to the right place, would it always do the right call?
Okay, so the loadable component is an implementation of a thing called the template method, which is a design pattern, which you can find in the Gang of 4 book. It's exposed to a user as an API called get. So a user news up the particular thing called get. The get does a check to see whether we're loaded. So it will do a check and is loaded will be where you make the assertion about, hey, is the navigation present or not? And then if it isn't present, the load method is called, and that says, okay, now do your stuff. Once the load method is completed, it will then call isLoaded again, just to make sure that everything loaded the way you expected it to. That's kind of cool if you're just dealing with a top-level page. But maybe you're dealing with a component sort of buried deep in the stack of things, right? In this particular case, what I like to do is model the way that the page is laid out. So going back to the Gmail example, maybe I want to get hold of that left-hand list of labels, right? So I new up the page object representing the labels, and I go new labels.get. In the load method of labels, what I would do is I go, well, I'm actually found in the Gmail homepage. So I'd new up a Gmail homepage, or if I was using a framework like Juice, which is the dependency injection framework by Google, I could just take a reference. I could be injected with a reference to the homepage, but I new up a homepage instance, and I go, get that, and then that would go, okay, fine, I know how to load the Gmail homepage, and how it does that is none of my concern. All I know is that once it returns, I will be on the Gmail homepage, and then I can go, okay, fine. Once I'm there, I can return straight away. And then isLoaded can call the gmonkey and just go, hey, look, is this thing present? I realize that was a really, really technical description, but put more generally, if I have a component that is nested within another component on the page, then the load method of that will call get of the component you're nested within. There's some documentation on this in the Selenium wiki, so if that description isn't particularly good, then go to selenium.googlecode.com, http://selenium.googlecode.com, and take a look at the wiki. And there's a description of this, I think, in the page object section of that wiki. Hopefully that answers the question. If you've got questions or that wasn't clear, feel free to just type a follow-up, and I'm sure Dara will read it out.
The next question we have here is from Xuan Lim. Have you had experience of integrating Sakuli with WebDriver? As a background, Sakuli is a framework that recognizes any non-web object on the page.
So I haven't had experience of it. I know that some people have. I do know someone who attempted to use the underlying technology that Sakuli uses to allow you to find by image, which was really, really impressive when they showed it off to me. I'm very wary of tools like Sakuli just because they are so totally dependent on how a particular thing appears on the screen. It means that you've got to make sure that the browser window, for example, has focus, which may or may not be a problem. So perhaps I worry about nothing. So the answer is I haven't had experience. I'm aware of some people who have tried it. The best approach I've seen has been someone using the underlying identification framework in Sakuli to add a custom by image approach.
Next question I have here is from a Vivek Varma. You said that the use of CSS preferred compared to XPath. My question is, compared with ID, is CSS robust?
So ID is really robust and very strong. CSS locators, there's actually a CSS locator to find by ID, so they could be equivalently robust if that's what you're relying on. If you start relying on the way that different things are nested, which is possible using CSS locators, then you might experience some breakage. But if you do, your designers and UX people will also experience the same breakage. So on the scale of things, IDs are the most robust. CSS selectors are reasonably robust and less prone to damage. And in my opinion, XPath expressions are actively dangerous and the least robust approach of all. I hope that answers the question.
The next question I have here is from Marius Bob. Did you use Selenium in testing mobile web apps? Is Selenium a reliable tool for web mobile?
Good question. So yes, I have used Selenium for testing mobile web apps. There is an iPhone driver and there's also an Android driver which are available. And both of those wrap the web view. Interestingly, one of the things we're working on is a W3C specification. So the W3C are the World Wide Web Consortium, and they're the sort of curators of many of the important specifications that we use on the web, including HTML. We're working on a WebDriver specification with them, which is buy-in from Opera, Mozilla, Google, and we're looking to try and persuade Microsoft and Apple and any other vendor that's interested to come and join us. Once that specification is complete, then hopefully a standards compliant browser even, will have a WebDriver interface available to it. I do know that the Chrome team are working on an implementation of WebDriver for Chrome for Android. So that's going to be extremely cool very soon. And someone demoed me recently using the remote WebKit debugging protocol to control Safari on iOS remotely. So we can use the actual browsers on the devices, although it can take a bit of jumping through hoops. Is it a reliable tool? I'd say that maybe right now the mobile drivers aren't quite as good as the desktop ones, but in the near future they're going to be as stable as the desktop equivalent. And certainly in the future, as we move towards a world where the browser vendors implement support for the WebDriver API in their browsers, we should see rock-solid support. So yes, it's an approach. The other thing that's kind of interesting are hybrid apps on mobile platforms. And if you're working on iOS and you quite like the look of the WebDriver API, do take a look at a framework called iOS Driver by Francois. Francois Reynard. Sorry, I'm just going to take a quick drink. iOS Driver by Francois Reynard. It's available on GitHub under his username. And that allows you to use the WebDriver API to programmatically poke at a native app and a hybrid app and the web views within a hybrid app. So it's really cool and totally brilliant. And Francois was also the guy who wrote Selenium Grid, so can't recommend it highly enough. So short version answer to your question, yes, you can use WebDriver for testing mobile apps, and it will be becoming more solid as time goes on, but I would already start putting some weight on it.
Okay, I don't think we have any more time really for questions right now. Thanks very much for today's webinar and addressing all these questions. There are a few questions that are quite technical, so what we'll do is we'll send these over to Simon and we'll put them together, then the responses in the form of a blog post, so you'll get a better understanding from them. And just want to thank Simon again for today's webinar. These webinars will be available on the EuroSTAR webinar archive, where we have over 50 webinars currently available. And by joining the EuroSTAR community, you get full access to these webinars along with over 600 software presentations, over 40 videos, podcasts, ebooks, and more. So thank you very much for attending, and we hope to see you again at future webinars.
Thank you, everyone.